when finding the factors of numbers, you can just try and find factor pairs. So 1, 6, 2, 3, and we're done. Now, when it says we add up the distinct factors of n other than n itself, that means we're not adding up 6, we're just adding 1, 2, and 3. So that would actually give 6 in this case. These are called the proper factors when we don't include 6. And in fact, we get an answer of 6 in this case. 6 is a perfect number because its proper factors add up to the number itself. Okay, we're not actually trying to get even numbers though. We're trying to see whether we can get 1, 3, 5, 7, and 9, or which one can we not get. Now, if we take a look at a prime number, every prime number just has itself and 1 as its factors. So its proper factors are actually just 1, which means the sum is going to be 1. 1 is definitely achievable. In fact, any prime number is going to give a proper factor sum of 1. So I don't need to look at any other prime numbers now. And I'm going to work my way up and see if I can which other ones I can get. That seems to be a good shout for this question. So I don't need to try 3. I would go with 4 next. So this gives me 1 and 4, which I ignore, and then 2. Okay, so 3 is obtained from that when I do 1 plus 2. Okay, then I ignore 5. I've done 6. Ignore 7. Let's try 8. So 1 and 8, 2 and 4. Ignore the 8. That's going to add together to give me 7. Brilliant. Okay, then 9. Could try 9. So 1, 9, 3. Okay, that's going to give me 4. That's great, but it's not of use here. 10. 1, 10, 2, 5. That gets me to 8, which is nice, but not helpful here. 12, 1, 12, 2, 6, 3, 4. This is going to be way too big. So I will add them together just to see what we get. 10, we get 16. 13, let's try 14. 1, 14, 2, 7. It's going to get me to 10. 15. 1, 15. And then 3, 5. Okay, that gives me 9. So the answer must be C. Now, that is an absolutely fine way to do this question. And for a question 24 on an intermediate math challenge, it doesn't seem too difficult compared to some of the earlier ones even. You just try finding factors of lots of numbers until you get there. If you can see shortcuts, such as you only need to look at one prime number and then you can avoid all the rest. When I did it originally, I um I don't know, I didn't seem to do quite as much work in, but I can't remember exactly how I got there. But anyway, the way I've done it here is fine. It didn't take too long, and we can see that 5 was left out. If you want to, I think a good shout, I mean, I didn't do it when I did the question, I must admit, is to think, why is 5 not possible? Okay, in the context of like harder questions, you might be, you could be asked to show that it's not possible. And here's the solutions that the extended solutions give. So they say, yeah, in the context of the IMC, it's enough to just select C, but to give a complete answer, we need to think about why n can't equal 5. So um, let's have a little look, read through this. Let's say we've got all of our factors, and then A, B, C, so on. They're going to be distinct. They're not going to be equal to 1. We are going to, of course, deal with 1. And we're going to get a sum. We're going to have 1 plus A plus B plus however many other factors there are. And we want it to equal 5. We can minus 1 from both sides, which means that all of our factors together must equal 4. However, there's no way that we can add 2 or more distinct factors to get a value of 4. We can't use 1, which means we're going to have to use something that's 2 or more. But as soon as you use 2 or more, then you're out of options for your other one. So that's a little basic proof why we can't get 5. It makes me wonder, like, what other ones are not achievable, or are all other values not achievable? These are like questions that can crop up, but I'll let you think about that one, and maybe I will too. Anyway, well done on your efforts here.